Okay, so my name's Sebastian Kaminski. I'm a structural engineer at ARP and director at a small charity called Engage for Development. Today I'm going to talk to you about a project we've been working on for the past 5 years with an El Salvadorian NGO named Redes, involving the development of a sustainable and seismically resistant permanent low-cost housing solution for El Salvador. Not very catchy, I know. Next slide. Okay, so El Salvador's a very seismic country. It's as seismic as California or Japan. These are some photos from the 2001 earthquake. Latin America itself has a housing deficit of 41 million homes out of the 2011 estimate. So there's a big demand for new homes and homes that are seismically resistant. Let's go to the next slide. Okay, so very quickly on existing housing, traditional housing styles. Firstly, adobe. Adobe's been constructed in El Salvador for hundreds of years. It can be very sustainable and very cheap if the local material is, if the material is available, the correct soil type is available locally. However, it's not very popular with the local communities. It's generally not very seismically resistant at all, and it can harbour disease-carrying insects. The second one is called Baireke. It's similar to the UK's wattle and daub. It uses a timber or bamboo frame clad in a matrix of bamboo or twigs or cane, and that's clad in a manure or mud. Now, this can be surprisingly seismically resistant. However, it's generally not very durable and tends to deteriorate over time. Currently, NGOs in Latin America and El Salvador are focusing on constructing new homes out of reinforced blockwork, prefabricated concrete, confined masonry, and this is an aluminium frame with synthetic material infill. These are just a few examples, but generally they're not very sustainable and they're not always that appropriate. They can be quite seismically resistant. So we discussed with the NGO if there's an alternative form of low-cost housing design for El Salvador that's more appropriate, sustainable and seismically resistant. And appropriate for the community, that's a key thing. This design would be constructed by the NGO as part of an NGO-led program involving the community in the construction of the houses themselves. So we started off with interviewing the community, running house planning workshops. The local NGO know the context very well. They've been constructing houses for over 10 years now, so they really understand the local context. And then we came across existing new low-cost housing design in Latin America that had taken traditional designs but engineered them and made them permanent. These are a few examples involving bamboo and cane. And so we thought, could we do the same in El Salvador? Could we take the traditional Baireke and engineer it and make it a permanent, better solution, rather than creating something brand new? So we started off doing a number of structural tests. These are some shake table tests, some tests on the cane itself, and this was to identify whether the house could be seismically resistant, and if we could optimize the design, reduce the costs, and simplify it for construction. So the final design, we start off with a simple reinforced concrete foundation. The concrete itself, within the concrete we can use rubble from previous houses, reduces the concrete quantity. 2 layers of blockwork form the upstand, which protect against flooding and rising damp, and that supports the frame itself. Next slide. Okay, so the frame itself is timber. We use timber imported from the US, which is available locally. This timber is structurally graded, it's from a sustainable source, and it's treated with a chemical that it's safe for the community to handle. We looked to see if we could source timber from the Central American region. However, we couldn't find any that was from a guaranteed sustainable source, and it wasn't treated with chemicals that are dangerous to handle. For all the connections, we use simple steel connections, which are designed to absorb earthquake forces. This is one of the seismically resistant aspects. They're galvanized, they're very durable, they have a design life of over 30 years, and they're very easy to fit. It's very hard to go wrong with these. Even if you install them poorly, they'll still generally work. For the roof itself, we use a cement fiberboard material, which is asbestos-free, very light, very durable, and it's a good insulator against the hot weather of El Salvador. We tie the roof down with hurricane straps to resist storm force winds. Luckily, El Salvador doesn't have hurricanes. Just waiting for the next slide. For the wall matrix, we use a cane, which has been used in construction for hundreds of years. This cane we buy direct from the local farmers, providing them with a new livelihood. We treat it with boron, which is a safe-to-use salt, which is available locally as a fertilizer. It's very easy to use, and it's very effective against termites and insect attack. And boron is actually the standard method of treating bamboo around the world. We nail that directly to the frame, 2 layers of chicken mesh either side of the walls, And finally that's plastered with a weak cement mortar to form the finished walls. The mortar itself, it doesn't have to be that strong. We found out from our testing, and that allows us to further reduce the cement content, making it more sustainable and reduce the costs. This is the finished house. We've actually further optimised the design from this photo. We're using half the amount of timber now. The design itself, it's very flexible. It's easy to make larger or smaller according to an individual beneficiary's needs. We can add rooms, we can take them away, we can adopt the whole house according to the plot of land that's available. El Salvador is generally very hot, with temperatures exceeding 30 degrees. So to keep the house cool, we use a variety of techniques to provide natural ventilation, high-level vents, large openings, cross-ventilation and thermal mass within the walls. Also having a lightly covered roof and walls and a large overhang reduce the solar gain, and this keeps the house very cool during the day. We conducted a number of evaluations. We've constructed 3 prototypes now. We conducted evaluations using focus groups and interviews. We found the beneficiaries really liked the houses because they had a modern look. Some liked them even more than the existing reinforced blockwork. And what was most interesting, we found that it's possible to change people's perceptions of bamboo, timber and cane from a poor man's material into something that they could use. A quick comparison here with the existing blockwork. We're trying to be fair here. We're generally quite similar. Sustainability, we're much better. We use 40% less cement. Cost-wise, we're about the same. Seismic resistance is better. Durability-wise, realistically, a masonry house is always going to be more durable than this, but ours can last 30 to 40 years at least. So we've constructed 3 so far. We're now in discussions with the government and other international NGOs about rolling it out across the country, and it's very easy to adapt a similar kind of idea to other contexts within the Central American region.